Hello, my lovelies. It's Susanna, and today I want to show you how to solve this problem. Inside a large square lies a smaller square and a circle. Here we can see our large square, and inside we have the smaller square and the circle. Both touch the sides of the large square and also touch each other at its center. So my small square touches the sides of the large square here and here. My circle touches the sides of my large square here and here. And these two objects touch each other at the center of this large square. Find the radius of the circle. Okay, we want to find this radius here. We are also given the length of the sides of the large square here and also the length of the sides of the small square. And we want to find the radius, and usually these touching points are very important to be able to solve problems like this. So I want to use this touching point here and connect the center of the circle with this touching point here, because this is also the radius of my circle. Then from this touching point to the corner of my square, I have the diagonal through this small square, so I call this length d. And then the only thing that is missing is here from my edge of the square to my center of the circle. This part here, I call this length x. And it looks like as if these lines form the diagonal through the large square. Why is that? Well, these lines go through points that all lie on the diagonal through the square. We have the center of the square, and of course the center of a square lies on the diagonal through the square. We have the corners, of course, they lie on the diagonal through the square. But why does the center of the circle is also a part of the diagonal through the square? Well, the reason for that is that if we look at the coordinates, if we create a coordinate system, for example, here, and we have our origin here, then all the points on the diagonal have the same coordinates, x and y coordinates. So I have for the center of my large square, this is at x coordinate 2 and at y coordinate 2 as well. So I have the coordinates 2, 2 for the center. Same with this edge here. This has the coordinates 4 and 4. So which coordinates do I have here for the center of my circle? Well, if I look at this distance here, this is the radius of my circle. And the same here, from the center of the circle to the edge of the circle, this is my radius. So the coordinates of the center of my circle are r and r, so they have the same x and y coordinate. So the center of the circle lies automatically as well on the diagonal through the square. Okay, now that we know all of that, maybe we start with d first. We want to find r in the end, but let's start somewhere. So what do we know about d? D is the diagonal through the small square. But d is also a part of this right triangle here. Because of the square, we have a right angle here, and we know the length of this side, which is given by 2, and the length of this side, which is also given by 2, and we can use the Pythagorean theorem to find the length of d. For the Pythagorean theorem, we first have to know where the hypotenuse is. That is the side that lies across the right angle. So in our case, d is the hypotenuse. And the Pythagorean theorem then says, take the length of one of the sides, so the 2, and square it, plus take the length of the other side, the 2 in our case, and square this as well. And then you get the hypotenuse squared, so in our case, d squared. Let's solve this equation for d. 2 squared equals 4, so we have 4 plus 4 on the left side, which equals 8 in total. And on the right side, we have our d squared. We want to solve for d, so we want to get rid of the square, so we can just take the square root on both sides of the equation. We want to solve for d, and if we take the square root, we get two solutions for d. A positive solution, d1, and a negative solution, d2. The positive solution is just the square root of 8, and the negative solution is negative the square root of 8. I'm not interested in a negative solution for my diagonal because I need a positive length, so we can just ignore this here. But the diagonal has a length of the square root of 8, so this is what we can see here now. Okay, how does this information help us now? Well, this is the center of the large square. And that means that this part of the diagonal has the same length as this part of the diagonal, because this here, they meet at the center. So the green line has the same length as the orange line. So x plus r, if we write this down, has the same length as the square root of 8. Let's solve this equation for r, because in the end we are interested in r, by subtracting x on both sides of the equation, so that x cancels out here and only r is left. And here we have the square root of 8 and we subtract x. So we can find r if we know our x. So let's try and find something about our x here. Okay, this is what we're looking for. We haven't really used these touching points yet in our calculations. We've already seen that from the center to this touching point, this is the radius of my circle. And here, the same thing. This is the radius of my circle. And we have automatically a right angle here and a right angle here. Why is that? Because the circle touches the square here. This side of the square is a tangent to my circle at this point. And the radius is always perpendicular to the tangent at this point then. So x is the diagonal through my small square here. The length of the sides of my square is r, so I can use the Pythagorean theorem again to find x. This is the hypotenuse again because it lies across the right angle. So the Pythagorean theorem says take one of the sides, the r, and square it, plus take the other side and square it, and then you get the hypotenuse squared, so x squared. We want to solve this equation for x this time. We were interested in x. We have 2 of the r squared on the left side, and here we have our x squared. We want to solve for x, so we want to get rid of the square again, so we take the square root on both sides of the equation. Like this, we will have 2 solutions for our x, a first solution, a positive one, and a second solution, a negative one. The positive one is just everything we have on the other side, so the square root of 2r squared, and the negative one is negative everything we have on the other side, so negative the square root of 2r squared. We are not interested in the negative solution because our x is going to be a length of a side, so it has to be positive, but this one looks good. So we can simplify this a little bit more because we have this r squared here in our square root. So let's write it like this. Because we have a product in here, we are allowed to write this one big square root as 2 separate square roots. So the square root of 2 first, and then we multiply it by the square root of the rest, so square root of r squared. And now we keep the square root of 2, but here the square root and the square just cancel each other out because our r is the radius and it's going to be positive. So we can just cancel these two out and only r is left. This is the length of my x. That was what I was looking for. If we go back to this situation here, I'm going to insert the value that I just found for my x. So my r is going to be the square root of 8 minus, for my x, I write down the square root of 2 times r, and now I only have to solve this equation for r. I have r here and a part with r here. Let's bring this part to the other side of the equation by adding the square root of 2 times r on both sides of the equation. What do I get here? I have 1r, and I add the square root of 2 times r. And on the other side, I only have the square root of 8 because these two cancel out. Okay, then I have my r's on one side of the equation, but they are not yet in one spot. If I want to solve for r, I cannot have two separate r's here, but because I have a sum here and r is in this part of the sum and this part of the sum, I can factor out an r. So I have r times, and what is left in my parentheses? If I factor out the green r, I had 1 r here. If I factor this out, only the 1 is left. Then I have the plus. And here in my second part, if I factor out the green r, only the square root of 2 is left. On the other side, I still have the square root of 8. Now, to be able to solve for r, we want to get rid of the parentheses, so let's divide both sides of the equation by 1 plus the square root of 2. Here, the same thing. This cancels out. Only our r is left. We're getting there. We have the square root of 8 and 1 plus the square root of 8 in the denominator. So this is our result for our radius. And if you want to calculate this, this is around 1.17, and we solved this problem. I'm curious how you solve this problem, so please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!